That's very cool. Look at that.
If you grip it all the way, it should all go up.
Wow. What is the liquid inside?
Just water and keep going. Yeah. What is heat? As we approach the dead of summer, this question might be pretty obvious. It means it is extremely hot outside. But that's not really what heat is. That's the temperature. That's an effect of heat that we feel relative to our own internal temperature. So really, what is it? What is heat?
What is heat? Heat is anything that causes a change in temperature.
Well, heat is temperature.
Heat, I usually define heat as energy output from a system.
If I'm remembering correctly, heat is, it's got to do with energy in a system.
Yes.
And I guess it's a measurement of the amount of energy in a system relative to something else.
Vibration of particles.
Vibration of particles, exactly. So it's all about how the particles are moving.
When we talk about heat, we are essentially talking about energy. When you put energy into a system, or when you put heat into a system, you cause the particles within the object or the substance to vibrate. The more energy you put into the system, the more the particles will vibrate. But if you're able to take energy out of the system, such as using a freezer or even a fan to blow air across you, particles of the substance will begin to vibrate less and less. Some molecules, such as water, are only able to hold a certain amount of energy before they have to change phases. For water, the phases are fairly obvious. Ice is the solid state, water itself is the liquid state, and water vapor is the gaseous state. Each of these phases is able to hold a different amount of energy. And once that threshold is reached, it changes phase. So when it all comes down to it, heat is just the measurement of how much a particle is moving. Unless, of course, you get really technical about it.
Q equals MS, change of T.
I saw that today.
Yeah, absolutely.
So now that we know that heat is just the measurement of how particles move when energy is input into the system, let's talk about the different ways that heat can be transferred from one object to another.
What are the three kinds of heat transfer? And then explain.
So conduction is when one thing that's hot and then it touches another and then it goes from hot to cold, so just conduction.
Conduction is when two things touch.
I like your shirt.
Thank you.
Big Bond is a great example of convection heat transfer because they use an oven.
What does a convection oven do?
Doesn't it make things move? Like
Oh, yeah, there's like the...
I don't know, I thought
It's
something to do
happening
with
right now.
magnets or...
If you feel it.
Like the air?
Convection is if you have a medium between them, right? Like air or wind, like the convection of the wind cooling me off.
But the sun gives us heat as well, and it's not direct. So solar.
Wait, you said it started with an R? Refraction. Radiation.
Radiation. So infrared radiation.
Yeah.
The spectrum is all radiation.
First, we have conduction, which is when two objects are in direct contact with each other and heat transfers from one object straight across into the other object. This effect is pretty obvious when you get in a hot car on a hot day and you touch the steering wheel and the steering wheel burns you. The second way that heat is transferred is convection. This is when a liquid or a gas, also known as fluids, transfer heat from one area to another. Think about when the wind blows. Sometimes the air is hot and sometimes it cools you off. That's just convection in action. Say that 5 times fast. The third way heat is transferred is through radiation. Right now, the sun is beaming down on me, so the wavelengths of infrared radiation are hitting me, and that's how heat is transferred via radiation. Radiation doesn't need a medium, such as air or water. It can travel through the vacuum of space. Think of when you park your car on a hot day. When you close your windows, radiation is what causes the inside of your car to heat up extremely fast. But if you crack your windows down a bit, convection is what allows the car to stay just a little bit cooler. Next, we talked about how a cup of coffee would cool down if you left it on a table at room temperature. What would happen to that coffee as it cools down? Would the rate of its heat loss increase, decrease, or stay the same until it was at room temperature?
This is literally like Gen Chem 1 test question.
I never thought about that.
Probably stay the same. Yeah, because actually, it might go faster because it's even cooler than it was before, which makes it faster. Yeah. So
I think that it decreases.
So
It increases, doesn't it?
It slows down. It's an exponential, like, kind of decrease. Like, so it starts out a little bit quick and then it kind of tapers off.
Finally, we talked about what would happen if you put an ice cube in a bowl of soup. Would the temperature of the ice cube increase, decrease, or stay the same?
Of the actual ice cube? Stay the same.
Well, it can't stay the same temperature or it would never melt, right?
it might stay the same because I disagree. I think it heats up. I think it heats up because if it's going into the hot liquid, then the temperature will increase.
It's going to stay the same temperature because there's a certain point that ice turns to water. So it's like at that certain point of temperature, 32 degrees, so the ice cube will still be 32 degrees until it turns to water, and then it will just be water.
But if you stay the same, then why does the ice cube melt? If the ice cube is melting, and has the temperature of the ice cube changed because it is melting? That's a cube no more, then it would be solid. Then it wouldn't be ice cube anymore.
Well, then it would stay the same because an ice cube has to be frozen at a certain temperature, so it would have to hold that until it breaks, and then it...
I go with him because, yeah, sounds good.
This all depends on how you look at it. If you see the ice as starting as below freezing, of course the temperature is going to increase until the ice melts. But let's just say it's at freezing temperature already. What actually happens is the ice doesn't increase in temperature at all. It flatlines at 32 degrees, and this is where the phase change happens. So we should know what a phase change is so that we can understand why the ice doesn't change temperature once it reaches 32 degrees. At that threshold, the ice has stored as much energy as it possibly can. And this is where something called latent heat comes in. More energy is being put into the ice, but instead of storing that energy, what actually starts to happen is the energy breaks apart the structure of the ice, and that is what becomes water. So there we have it. Heat is just a measure of how particles move when you input energy into the system. The three methods of transferring heat from one object to another are conduction, convection, and radiation. And finally, a substance in its solid state can only reach a certain threshold of temperature, at which point it stops warming up, and latent heat takes over to break down and cause a phase change.
That was super fun.
Is that the end of the interview?
Awesome. Well, thank you. Good.
This has been fun.
Okay, well, thank you. I appreciate it.
Thank you so much.
Killing it. We're sucking today. Ask us more questions.